Herstein Abstract Algebra 3rd edition, Chapter 2, Section 1, Problem 1e. Determine if the following sets G with the operation indicated form a group. So our set G is the set of all rational numbers with denominator divisible by 5, written in reduced form, and our operation A star B is addition. A star B equals A plus B. So we're going to need the definition of a group. These are our four axioms that the problem is asking us to check. And then there's a reminder that a rational number is the ratio of two integers and the denominator cannot be 0. So let's check our four conditions. Number 1 is the closed condition. Here the question is, if I take any two members of the set and apply star, do I get a member of the set back? So I say that A equals A naught divided by 5k and B equals B naught divided by 5l. So any members of the set can be expressed this way. And here A naught and B naught are integers and k and l are positive integers, right? So these are members of the set, so they're rational numbers with the denominator divisible by 5. That's what allows us to express A and B this way. What happens in A star B? Well, A star B is just A plus B. That's our operation. And so when we add these together, we see that the numerator is L A naught plus K B naught. L, A naught, K, and B naught are all integers, so their product and summation is an integer, so our numerator is an integer. And then our denominator, 5KL, it's divisible by 5, because there's a 5 in there, and we need to check it's not 0, but K and L are positive integers, so 5KL is a non-zero number. Number 2 is G associative. We need to check that these two equations are equal, just by the definition of our axiom for associative. And here star is just plus, so we see that A plus B plus C equals A plus B plus C. Number 3, does this group have an identity element? So this is an element such that A star E equals A and E star A equals A. Anytime we're working with addition, easiest thing to do is check if 0 works. Here 0 does work. Is 0 a member of the set? Well, we can express 0 as 0 divided by 5, where 5 is a multiple of 5, divisible by 5. So E equals 0 is our identity element. Number 4, for the inverse condition, we take the identity element we solve for in part 3, and we say, given any element A in G, can I find an element B such that A star B equals E and B star A equals E? So both left and right multiplication of these two elements gets us back to the identity. So if we let A equal A naught divided by A1 is a member of G, then I'm claiming that B equals negative A does the trick. Again, with addition, our common guesses for the identity element are 0, and the common guess for the inverse element is just the negative, right? 5 plus negative 5 equals 0. So here we just need to check that A star negative A equals E and negative A star A equals E, which we do, and we conclude that G comma star is a group.